Tere päevast! Good afternoon, everybody. I am very happy today to introduce to the audience a technology transfer expert and very, very good human from United States with tens of years of experience in university, in startups, in technology transfer, who has experience from United States, from Ukraine, and now from Estonia, John DesRosier. We have approximately 1 hour lecture here. After that, we have a questions and answers session, and hundreds of people who are watching us through the internet. You can write your questions to the YouTube too for the questions part, and we will forward them to the John. And please be active in thinking and active in asking and discussion. Thank you. John, the floor is yours.
Thank you. Thank you, Alan. This is a very nice arrangement. I'm not used to speaking like this kind of arrangement, but this is very, very nice. So what I really wanted to talk about today was, as Alan said, my experience with technology transfer and working with academic researchers, between them and industry. I really wanted to talk to you a little bit about how in the United States we have actually developed the university culture that really is necessary to have successful relationships with industry, successful relationships to commercialize your research discoveries. And so I've got a sort of a multifaceted presentation, but first of all, I wanted to acknowledge my sponsor. And I'm here really by the courtesy of the Fulbright Specialist Program. It's a program of the U.S. Department of State, and I feel really fortunate to be able to participate under that program. So they are my sponsor for being here. The project that Talltech really wanted me to come over for, wanted somebody to come over for, was really to review the research commercialization strategies and practices in the United States. So again, taking promising things from the university and getting them into the commercial sector. Discuss the strategies for how to work with these very early stage discoveries. They're not true products that we have at universities, and how we deal with that in the U.S. Paying real close attention to the entrepreneurial activity in startup companies, which have gotten much more popular in the United States, spinning out of the universities. And then really talking about trying to create this culture of technology transfer on campus. And as you're going to hear, maybe you'll hear too much, more than you want to hear, but it's a big deal traditionally for universities who have had centuries of advancing knowledge and publication to now working with industry real closely. So I'm going to talk about that, how that's really proceeded in the United States and where we are now. That's right. Okay, so yeah, so I'm going to talk about, the history of this development of technology transfer culture in the United States, historical view. We'll talk about then going about the actual challenges of trying to commercialize these early stage discoveries. We'll talk about, that'll lead us into conversation about startup companies. And then I've been here for a whole 5.5 weeks. It doesn't make me maybe a knowledgeable person about what's going on in Tallinn, but I can give you some of my observations about the innovation and entrepreneurial environment that I've seen. Just by way of background, I was trained as a scientist, chemistry, microbiology, and biochemistry. So when I've been here meeting with people who are doing electronics and electrical work, I haven't really understood what they were saying, but I could ask about applications in these kinds of fields. I was a college professor for a while, teaching microbiology. I was in a startup company back in the 1980s, and we developed tests for detecting disease-causing bacteria in processed foods. And while I was there, we got 4 products to the market. I moved from there to the University of Washington in Seattle, and where I then was engaged in technology transfer, doing that and also working in the medical school there, and all of it in the health sciences, health-related technology. And I was working to really try to bring in more research funding from industries. So that was sort of sitting at the interface between the university and companies. And then I closed out my working life by working at a granting agency. We had a state granting agency in our state of Washington, where Seattle is, that we made grants for trying to advance early stage technology to the market. And that was an enjoyable, so I was giving money away, and that was a very enjoyable job because people wanted to talk to me. They wanted to hear what I had to say. And so then while I was there, we gave out about $110 million over 10 years for early stage technology. Since I retired 7 years ago, I have done some consulting work on biotechnology commercialization in Ukraine. And I've also been a board member of a Canadian business accelerator that I thought was really interesting. It was in Vancouver, BC. So that's where I've developed my perspective that I'll be talking about today. Reference points. So I have to point here. This is where I grew up. This is where my grandparents emigrated from Finland in 1903. They came up here, a lot of Finns up here. But University of Washington here is in Seattle, and you may know Seattle from Boeing Aircraft and Amazon and Microsoft and Starbucks. And I've also done a lot of work at the University of Georgia, where I live now. It's about 120 kilometers east of Atlanta. So my academic perspective, really with working with universities, is in these 2 locales. And I am not employed by, I say this all the time, not employed by either of those institutions anymore, so I'm not here speaking on their behalf. So let's start out with, what's the traditional role of the university? Am I blocking your view, by the way? Okay. What's the traditional role of the university? It doesn't matter, I think, where you go in the world. It's 3 things. It's teaching, research, and public service. So we train undergraduates, we train graduate students, professional students, postgraduate. We're really trying to help them develop skills in a profession, try to help them contribute to society, be good citizens. Research, we're charged with advancing knowledge, expanding the horizons of knowledge, how things work, especially in the biomedical sciences. We're creating new ideas and primarily demonstrating your productivity by publication. Public service, the academic environment has expertise in many, many, many fields. They provide that expertise to government, to industry, through white papers, through a whole variety of mechanisms. So, but in 1980, this may be overly dramatic, but I say an earthquake hit American universities. So it's overly dramatic, but I think it sort of represents that there was a big culture change in the United States universities in 1980. And what happened was our federal government passed a law that added economic development to the responsibilities of the university. Okay, the university didn't really think about that beforehand, and our federal government, by just passing, president signing a bill, says, okay, you guys are now involved in economic development. And that's called the Bayh-Dole Act, and I'll give you just some snippets from it. It's very extensive on things that universities have to do to comply with it, but this was a real big change. Universities really didn't necessarily think that they were helping to develop the economy before that time. So what was the rationale for this new law? Well, first of all, 70% of university research was funded by our federal government, okay? So they were paying the bills for all of this research. And they said that money that they're paying to the universities to do the research should be an investment. And it's not only an investment in new knowledge, but they expected returns other than publication, okay? And those returns were a form of ideas for new products, services, and companies based on university research. So they said, that some of what you're doing may have practical import, and that practical import can be in the form of products, services, and new companies that are based on that research. And they said those new products, services, and companies, they would stimulate jobs, they would add to the gross domestic product, and all of that they phrased as contributing to the public good. So, 1980, universities are now in the business of economic development. And what I should say, it's important to say, the government didn't tell us, forget about doing basic research and how things work. They didn't say that at all. They didn't say redirect your research to something more applied and start developing products. They didn't say that. It was in the normal course of your research, if you make a discovery that you think has practical significance, commercial significance, then you the university, need to try to get that into commercial sector. So, under this law, what was required of the universities? Well, first of all, they would own any patents that were filed on commercially promising research discoveries. So one of the things in 1980, any intellectual property, any patents that were made, that were developed on university research discoveries prior to 1980 were owned by the federal government. Our federal government had 28,000 patents under management, and 6% of them were actually in the commercial sector. So they did a miserable job on this. Now they pushed the work then to the universities. So by dole, this law is really part of our patent law. And so patents are a form of intellectual property. So this is, you'll hear me say more, but at universities, we didn't normally think of our research results as property. We didn't think about that. But patents are important because they provide an incentive for companies to actually commercialize whatever that patent covers, okay? So then the second part of the law said, so universities will patent, not all, but as appropriate, patent research discoveries that have commercial importance. And they'll transfer those patent rights to industry, and the companies then will develop new products and services. And that transfer, we call that the process technology transfer, but it's actually the actual handoff to industry is under the form of a contract called a license. And so this is now called licensing. Universities would be in the licensing business. Another part of the law said that, licenses uniformly have financial return back to the patent holder, back to the university, and that universities, if there was any financial return, they could keep all the proceeds, but they had to share some of that income with the researchers, with the people that developed the invention, in order to really to help them, encourage them to participate in this. Okay, so if the university makes any money on this, some gets shared, but generally about a third of that gets shared with the developers. So why do they concentrate on patents? Well, product development is very expensive. So I'm coming from the biomedical sciences. So if you are really a company that's going to take a new drug to market, that could take 5 to 10 years and cost $500 million, $600 million, a huge amount of money, huge amount of effort, time, and really, in order for a company to put in those kind of resources, they need to have intellectual property protection, because otherwise, if you spend all that time and all that money taking that drug to market, and then it hits the market, and then your competitors can make the drug and sell it on their own, that doesn't justify the expenditures that you've made in your resources. So that's what the patent does. It gives a period of exclusivity. So a patent is like, it's property. It's putting a fence around whatever that invention is. And the example I'm using is inside that fence is a new drug. And that fence keeps out other people. So, intellectual property, as we'll talk even more later, it's often one of the companies, especially a startup company, it's one of their most important assets that they have. So, why did the government do all this? They didn't do this just to be mean to the universities. They really looked at the American economy. In the 1970s, we were talking more and more about the knowledge economy. So, our government realized that going forward for economic growth, our population was increasing, and we had baby boomers like me coming into the workforce, that we couldn't rely on traditional industries, especially those related to natural resources, like agriculture, mining, logging, fishing, that really there had to be other ways to help grow our economy. And that then the discussion was on this knowledge economy, that it's going to be innovation and your new ideas that can contribute to economic growth. Where do those new ideas come from? Well, a lot of them come from universities. And who funds most of the research at universities? Well, it's the federal government. So that's the rationale behind why this law was created. University, how do we react to that? Well, there were some people that rolled their eyes and said it's just one more set of federal regulations we have to deal with, because there were some things that they have to do under this Bayh-Dole. Other universities said, oh boy, this is an opportunity to make a lot of money because we're going to get all this money coming back in. So those are kind of the extremes. But practically speaking, in order to comply with this Bayh-Dole Act, this new law, universities had to develop new policies, practices, infrastructure to comply with that, to actually do the work that was being asked of them. They were forming technology transfer offices. They had to learn how, why, and when to do patent research discoveries. Do we file a patent on everything? How do we do that? How do we even deal with patents? They weren't working with patent attorneys before that time. They had to learn how to do licensing. They had to learn how to interact with companies. Prior to that time, the university's interaction with a company is they'd buy things from the company. Now companies sort of look like a business partner, and that wasn't always comfortable for a lot of people. Licensing is, again, it's not. There's a negotiation that happens. It's often contentious. So the university really didn't understand much of this, and this process in which you learn all of this. Well, and the other thing is, what I don't have on here, is you have to work with your faculty now, your researchers, and tell them this is available. These kind of services are available. So if you do see something of commercial import out of your research, tell us. So this is what I call that whole process of really developing your culture of technology transfer, and particularly working with your researchers to help them understand that this is available. You're not forcing them to do this, but this is available to them if they think if they think their research has commercial import. And to tell you the truth, the sooner you talk with researchers about that, you may have a better outcome. If they're going to do a bunch of experiments that are heading in a certain direction, and they come and talk to you, you might be able to help them not control the research, but advise them on which kind of direction the research should go. And I've done that a fair amount. Probably most importantly, universities have used the federal rules as the standard for how they manage all their intellectual property and all their tangible property. I'm not going to talk about tangible property today, but Tangible property is things like, if you're an agricultural university, you develop new plant varieties. It's software, it's cells and clones and DNA and those kinds of things. That's tangible material, but universities have used that federal legislation really as to develop a single policy generally that covers everything that they do, including copyright. So universities have had to reflect, how does economic development fit into my mission? And as we've talked about, it's not part of the traditional university mission. So University of Washington, where I was, I looked it up, it's formed in 1861. University of Georgia, 1785. We look across the country here at Tartu, there was 1632. So these institutions have developed a culture for hundreds of years that has nothing to do with economic development or working closely with industry. And this is a big cultural shift now, doing this technology transfer, this economic development stuff. And I have to tell you, universities were 40 plus years into this new law, and universities still struggle with that question. Where does this fit into my mission? And I think that can be to their detriment, I think, in the long run. But so the universities then have had to develop a new perspective. How does this fit in, economic development fit into my mission? We need to reframe what we do. So we've still got the same mission. I don't think any university has said, okay, this is a fourth mission. I think what they've said is it folds into their current mission. So in teaching, now we talk about training the workforce. We didn't talk about that before. This has an economic incentive to it. Research, we've already talked about that, about new ideas. But research, those new ideas, we've spent a lot of time in the last 20 years in the United States talking about entrepreneurship and startup companies. And when I started at the University of Washington in 1989, I could name the number of startup companies that came out of the health sciences at my university, or maybe 5, 1989. And I can guarantee you it's a lot more now. So, but this is particularly the hottest thing in the United States right now with regard to these kind of programs. It's starting new companies, and how can the university facilitate that? And public service, we've got closer collaboration with industry. You have people here in Anumai's shop that basically are there to stimulate more collaboration with industry. So we've gotten a lot closer to industry. Although I don't have a slide for this, if you had to guess what proportion of the typical university research budget was from industry, does anybody want to take a guess? 6%. 6%. Sorry. It's low. It's very, very low. The federal government is still our biggest funder of research. There's some psychological effects of the legislation, I think, part of this culture. This notion of property. Research data and materials are now considered property owned by the university. When I started out my graduate career in 1974, nobody talked about property, intellectual property. This is new. People were protective with their research data, but they didn't consider it their property. So this notion of property ownership and who owns it and all of that is very new, and it's a little bit unnerving for people. We started calling faculty researchers inventors, and that was completely new. People in the United States, if they're thinking inventors, are thinking of Thomas Edison, or if you're in Europe here, you're thinking about Tesla or somebody, but they still don't think of themselves as inventors, but we start calling them inventors because a patent covers an invention, and the people that developed it are the inventors. And these are just a few of the things that I think I've seen. And the boundaries between universities and companies has become much more blurred. And that hasn't been always very comfortable with people. I think there are people that decided on an academic career because they didn't want to go in business. They thought business was somehow dirty in a way, but they didn't want to go into business. That attitude has changed, but this boundary then has become blurred, and they're, the university culture and the business culture are completely different, and that's part of what I've done in my career is really try to bridge that to help people on both sides understand what they're dealing with in regard to these cultural differences. So, university large scale, is sort of summarize, in 1980 gave birth to large-scale university technology transfer. There were a few universities in 1980 that were doing this. Stanford was one of them, MIT, University of Wisconsin, but not very many. And I think it's what the best thing a university can say right now, if they've really gotten this into their culture, is that tech transfer helps fulfill the mission of the university. It's part of our mission to make things, it's part of what the investment of public funds has done. It's a return. So it's taking the property rights that came from research, getting them to the industry for development of new goods and services through a process called commercialization. Commercialization, those new products and services, fuels economic growth and overall enhances the public good. Again, in tech transfer, in the United States, the people who do this, they always talk about the public good. They aren't talking about necessarily making tons of money. They're talking about the public good. That may surprise you, actually. So 40 plus years after legislation, where are we? University administrators have become much more comfortable with this. As I said, there's still some universities that still haven't figured out exactly how this fits into their mission. But by and large, we've developed a culture of tech transfer. My last count, there are over 300 university tech transfer offices in the United States. Significantly, I think this one, faculty who have ideas and they'd really like to make a wide impact with their research, and I'm talking from the biomedical side now, realize they're not going to do that through publication. If you have a new diagnostic method for heart disease, if you have a new drug for cancer, if you have a new device for measuring cardiac output, basically, if you really want to see your idea get into wide use, you have to work through a company. The university can't do that. The university doesn't manufacture these things, doesn't take them through regulatory approval. So you have to work with a company, and that's significant. That, again, faculty who really want to make an impact. The other thing that's significant in the last maybe 10 to 15 years, and especially now, is that our students and postdoctoral fellows are the driving force for starting new companies. They are much more entrepreneurial than the people that were coming through the programs before them. And so they're sort of taking their careers in their own hands and feeling like they can guide their own career. As where someone like me took his first job, I thought I'd be there for 40 years and retire like my dad. That's not the case anymore. So we'll segue into the realities of tech transfer. So these things we call the inventions at universities, they're really at a very early stage. They're ideas, they're concepts, and consequently, we don't really know if they're going to mature into what the idea was formed about, what the purpose was. So they're at very high risk for proving their value. And what does it take to prove their value? Well, it takes money and skill, but primarily money. You have to go through a whole series for drugs. Again, there's one thing between doing something with cells in a petri dish and another thing with putting that drug through 1,000 patients in a human clinical trial. There's a big process that goes through there in the development. So that takes money and skill. But without money, you're not going to, that money is there to reduce risk. You'll hear me say that several times. And without that money, you'll never really test whether this idea has any real merit. Money. So our federal government does not really, so we talk about R&D, research and development. They don't really provide a lot of development money to universities. So universities are kind of on their own to try to figure out how we can try to minimize some of the risk in this, because trying to get a company interested in an early stage idea, the earlier it is, the less likely they're going to, an established company, the less likely it is that they're going to want to take that idea in-house and develop it. So universities are really trying to figure out how we can reduce the risk more to get them more palatable for companies to license. Established companies have a lot of money, but they stay away from high-risk projects. And in the pharmaceutical world, it's interesting that a big company, big pharmaceutical company, would rather watch a small company, a startup company, move something forward, reduce the risk, and then, after 5 or 6 or 7 years, they'll buy the company for $20 billion. I mean, it seems crazy to me, but they're willing to pay a huge, huge price later when the risk has been reduced. But this is the central thing that we have at universities, is that these really early stage, high risk, in my day when I started out, people called them embryonic inventions. So again, money to reduce risk. So invention has 2 components: conception and reduction to practice. So here's the idea, here's making it work. These reduction to practice funds, there are not a lot of them in the United States, to tell you the truth, for universities. Some universities use some of the revenue that they get from their license, and they'll put that in a little fund to do some reduction to practice or risk reduction work. Those grants are often $10,000, $15,000. We have state government funds, like what I did. Our typical grant for a university, again, to reduce risk, was about $250,000. And usually this risk reduction occurs, there's sequential funding, and after each funding, the risk should go down a little bit more and make you more eligible for the next type of funding. And so at the highest risk, the real high risk stage are these public funds. Later on, you can attract other monies as the risk goes down. Well, so this idea of risk reduction then, that's really created the momentum for startup companies in the United States coming out of universities. So startup companies are based on risk. They don't have any choice. They don't have any sales revenue. They can't get loans. What they have are basically ideas, intellectual property, and a team. But they don't have any money. But you put that together, that group of people together, and now the university has said it's not our problem anymore, it's your problem. Okay, I don't mean that pejoratively, but now we have somebody else who's going to spend all of their time and energy taking that idea, taking that intellectual property, and trying to get it into the marketplace. Again, startup companies, when I first started in this, there just wasn't even on the table, and now it is very much so. And so the startups then, have become real important ways to try to get this early stage university inventions into the marketplace. And the university then gives a license to the company, and then it's the company's responsibility to take that further. So in my time, we've changed. I've gone from, when I started this, how can I find a large company to license this promising technology? And we did license to some big companies, but big companies have gotten even more risk averse over the years. So we've gone from how can I find a large corporation to how can I find a startup company, or how can we create a startup company to take this forward? So universities and startups, as I said, the momentum is really coming from these people. They really want to have some control over their careers. They become entrepreneurs. They have faculty people, like I said, behind them who really want to make a wide impact with their work. And so universities now really encourage researchers to be involved in starting new companies. Typically, in my experience, it's very rare for the university faculty person to leave with the company and go out with the company. They prefer to stay inside the university. And then it's the people that are training in their labs that go out and into these organizations. Universities then, over the years, the last 15 years, maybe even 20 years, really have started to experiment with ways to advance startup companies. I highlighted this because not every invention not every discovery is appropriate for a startup. And so, one of the question is what kind of intellectual property position can you get, or can you even establish a patent position? And so universities have also started to, in a sense, counsel or mentor, or to bring in people to mentor these young companies to say, is this really worth your time to do this, because this might not be appropriate. I would have venture capital people tell me that they're looking for the next best thing so they can make a lot of money, and they would tell me, that's a product, it's not a company. They were looking for, as an investment opportunity, they were looking for a company that would have a wider breadth of products to take to market as opposed to one single thing. There's nothing wrong with a company that does one single thing, but it's unlikely to get real high quality venture capital investment. So how do universities promote startup formation? You see an awful lot of this here. We're teaching faculty and students about this. We're providing mentors to them. We have new curricula focused on entrepreneurship. So in 1980, probably the only people at the university that were thinking about entrepreneurship were in the business school, and they were studying this, case histories and things like that. But now, even at Talltech here, my understanding is that every graduate has to have at least one course in entrepreneurship. So we have business plan competitions and pitch competitions where in 2 minutes, you make somebody want to spend their money and invest in your company. Some universities have, I've seen $10,000, $15,000, $20,000 awards for the best business plan. As I said, some universities have used some of their licensing proceeds to help move things along. They have makers spaces. You have at least one here in this building for prototype development. If you actually want to go in and you want to create something from scratch. Often now these are with 3D printers, but in the old days they were kind of old, sort of a workshop with industrial equipment in it. Shared workspace, incubators for startups. Incubators aren't anything new, but the incubators now come with, they're not only space, but they come with sort of what they call acceleration programs to mentor you. We have hackathons, which at my age, I still don't understand, but you get a bunch of young people together and for a weekend, and you give them a problem, and they organize in teams, and they come up with a solution to the problem. It's a great idea. I can't imagine spending a whole weekend doing that, but I think it's a nice idea. And again, I'm just impressed with how much universities now are doing with entrepreneurship, and I hate the word empowered, but students are feeling empowered now that they have actually some control over their careers, and I think that's really, really cool. University of Georgia has an innovation district. They're trying to keep their startups close to the campus, and part of the attraction to that is the campus is lined by really old buildings, and those old buildings get fixed up and new. They've got the exposed brick and all that kind of stuff. I know, something 80 or 100 years old is nothing compared to your old town that goes to the 1200s, but those older buildings, the young companies like to be in those. So anyway, they're trying to keep things closer. I think the University of Washington has also been working on that. So going now, that was pushing tech transfer, pushing these high-risk things into young companies. I like to talk about the environment for startups. What do you need? What does a startup need for success? Well, you need a good idea, and that idea should address an unmet need. There needs to be a market need. Just because you have a good idea doesn't necessarily mean that people want that. And we see a lot in the universities where it's a solution looking for a problem, and we can't find the problem that this addresses. And I've seen that plenty of times. You also need to figure out if you can establish an intellectual property position. Not everything is patentable. And if the idea is already out there, you can't get a patent on it. This is really important. The more experienced leadership you have with these startups, the more investable they'll be. I can remember talking to venture people. I pitched an idea about, here's a potential new drug for hepatitis B. Suffered worldwide market, and the investor said, well, who's running it? And I said, no, listen to the market size. And he said, no, who's running it? So they didn't care about the technology or the drug opportunity. They wanted to know who, this was an investor. They wanted to invest in something that was going to, if it was going to take that long to develop, that they wanted somebody experienced leading that. That's really difficult to find those people. Even when I talk to colleagues in Boston and San Francisco, they tell me the same thing, is we just can't find enough entrepreneurs. Now, I don't feel bad for them because I think they're doing pretty well, but highly experienced entrepreneurs are difficult to find. You need a workforce, you need people. Some of those people are in business, some of them are service providers like patent attorneys, accountants, attorneys to help you set up a company. Money, of course you need money, grant money or investment money. For some things you need facilities and equipment. If it's a software, IT kind of thing, well, maybe you just need some computers and a desk. But if it's heavy on engineering or biomedical, you're going to need a lot of real sophisticated equipment. This one I can't say enough about. It's opportunities for networking. You really need to bring people together in the community, talking with each other, because an awful lot of success, one of the requirements for success in a startup is luck, and you can't plan for luck. You don't know who you're going to talk to, because and if you aren't talking to people, you're missing out, because people want to help, people will give you ideas and things that you'd never thought of. So these networking opportunities are extremely important. About money, sources of money. So money is in two forms, grants and investment. These startups can't get loans. There's nobody will take a risk on them. If it's an investment, you're selling stock, you're selling part of the company, and that's called dilutive funding. So your ownership position is diluted a bit, because when you sell stock, you don't have as much a percentage of the company as possible. Grants are being non-dilutive, and young companies love grants because they don't have to sell part of the company. In the United States, now this is money for startups, not universities. So in the United States, we have two big federal research programs, research funding programs that provide grants to small businesses. And the two of these last year awarded $4.3 billion in grants to small businesses, ranging from probably $150,000 to $750,000. And as I already talked about, our Life Sciences Discovery Fund, we made grants to small companies, typically in the range of about $250,000. On the investment side, people will start out with personal funds. They'll go to friends and family. People are always warned about trying to get your friends and family because in the United States we talk about family gatherings like at Thanksgiving and Christmas, and you're sitting around the table and your company isn't exactly doing what you thought it would be doing, and they're your investors. People discourage friends and family. There are angel investors. These are wealthy people who are willing to invest in high-risk things, high-risk endeavors. Occasionally, you'll see governments invest. So this Accelerex group that I was involved with in Canada was a government entity, and it made equity investments. It made stock investments in young companies. Venture capital ranges from small funds of $10 to $20 million to funds ranging up to $1 billion. They're managing other people's money and investing it for them with hopefully a return. And now we're seeing large companies actually make actual investments, buy stock in these small companies. But it's not very often, but we see that. But if we go back on that sort of risk reduction idea, generally, as you progress through these, the risk has gotten reduced. At each one of these, when I said that funding tends to be sequential, each one of these basically is designed to reduce the risk further. And so, and that's just the natural progression of how investment works. So the people here are sick of me saying this, but it's technology transfer is a contact sport. You've got to be out talking with people. This is one of the things my boss told me when I first started in the office. I had no idea what he meant. Okay, Don, that's contact sport, okay. But that's this notion that you have to be out there talking to people, and your tech transfer staff needs to be out there talking to the researchers. Researchers, if they have entrepreneurial interests, they need to be talking with potential entrepreneurs. Our National Science Foundation, which is another great big granting agency, has a program they call Innovation Corps. It's abbreviated ICOR. And what this requires under this program is they have the researchers going out and talking to potential customers to try to get an idea of an unmet need. What are their unmet needs? It isn't that you go and talk to them and say, hey, we invented this thing that does this, will you buy it? Because that's not what it is. People will say, yeah, sure, I buy that. And you don't know that you're getting any valuable information. But if you go and talk to them and say, so a clinician, so, I understand you're a cardiologist and you have to measure blood flow. How do your existing systems work? Are you getting the data and information? Are you getting it in time? Are you getting so that you can make high quality decisions? And the cardiologist might say, well, no, this is what we have, but I'm not happy with it. I wish it did this. Those are the conversations that this ICOR program encourages people to get into. And it's rigorous. They may want you to talk to 50, 60 different potential customers. It's good, because then you're really trying to identify an unmet need. And this program results in some people saying, yeah, it's not a good idea, it's not a company. Other ones saying, we can change course here, we can change course 30 degrees, and yeah, so now that I've got this feedback. So it's very useful, and it's part of this contact sport idea. The notion behind the program is, the researchers follow ideas, companies follow markets. That's part of the cultural difference. So again, part of this contact, researchers, talk to potential customers, they talk to entrepreneurs if they're interested in a startup. Entrepreneurs are always talking to investors. When you talk to an investor, you say, okay, you're not interested, whom else should I be talking to? So those are the conversations you have. And those kind of opportunities are really important. And again, these networking opportunities are where the luck happens. So this tech transfer cycle, university generates new technologies, commercially promising are patented. I haven't talked much about this, but the university markets these. They tell potential licensees that we've got this invention for license. We've got these patents. So there's marketing involved. We haven't talked about that. Ultimately, if you find somebody interested, those patents are licensed, often to startups. Startups have to assemble a team and raise money. Hopefully, the product gets developed completely and hits the market and is sold. Royalties, percentage of sales are paid back to the university, and those royalties help fuel further invention. So this is a diagram that's put out by the Association of University Technology Managers. So this is the professional development organization for people that do tech transfer at universities in the United States. And these are their data. This is from 2022. So the cycle is, university research and development leads to invention. Those inventions are evaluated, and as appropriate, they're patented by the tech transfer people who market the inventions, find licensees, negotiate a license. The company develops the product hits the market, it enhances solves problems in the market, creates jobs, and leads to GDP growth, and ultimately there is the financial return back to the university that they again plow back into some of the research, as well as incentive for the researchers to participate in this. So this survey was based on about 200 different U.S. Universities. The previous year, they had gotten 24,000 reports of new inventions among them. Okay. Of those 24,000, the universities filed close to 17,000 patent applications. That same year, they did close to 10,000 licenses. Now, this wouldn't be necessarily coming out of these because it can take 1 to 5 years to find a licensee, but they did 10,000 licenses that year. There were 850 new products that hit the market. Again, not out of these necessarily, but these have been in development for quite a while. But 850 new products, almost 1,000 startups formed, and going back, they still had 6,800 of their startups is still in existence. So this is the sort of the mechanical view from the eyes of the university. When we look at why the government caused the earthquake in 1980, this is also from the Technology Managers Association. This is what our government envisioned. So this is between 96 and 2020 on university inventions, if you will. 6.5 million jobs supported, $1 trillion contributed to GDP. I'm not familiar with gross industrial output, but it means that if you produce something and you sell it to another company, that doesn't get involved or in the GDP calculation. But so actually, 1.9 trillion in economic activity. Since 1996, 17,000 startups formed. 6,800 still in existence. So as you probably know, most new companies will not survive. But lots of startups coming out of universities. 73% of the licenses that they did were to small companies and startups. And then since 1980, there were over 200 new drugs and vaccines and therapeutic things that were produced by the universities. So again, this is what our government wanted to see, and this is what the professional group reports back. So I'm going to go back now to talk a little bit more about the ecosystem. We got a few slides left. So this knowledge economy, we now call it really an innovation economy. We talk about the surroundings, the innovation ecosystem. In order to make this work, you need new ideas, you need people, those inventors, technologists, entrepreneurs, service providers. These are the patent attorneys and accountants and people like that. Obviously, you need companies. You need facilities and equipment, depending on how complicated your invention is. You need money for the original research, so the universities have to keep bringing in research money, sponsored research money, in order to create the ideas. But then you need these risk reduction monies and also investment for young companies. As I said, experienced entrepreneurs as CEOs would be great, but also as mentors and role models, entrepreneurship training, opportunities for networking, this contact sports stuff. I'm sorry to beat it into the ground, but it's real important. And something we don't talk a lot about is I think you need to have close collaboration among the university, industry, and government. They need to be talking together. We have in our United States what we call round tables, where several times a year those three parties will get together and talk about their mutual interests. And it's really a good idea for government to understand what universities are facing, as well as what industry is facing. So, Estonia, what have I seen? Well, I did a little bit of homework before I got here. I saw that Estonia has the highest rate of startup formation in Europe. I read an article that said Estonia has been called the new Silicon Valley. So I thought, wow, that's great. Why do they need me? What am I? I did. I asked them that. What this says to me is if you have a high level of entrepreneurial activity, it means that people can tolerate risk and do not fear failure. And that's really important because in some cultures, if 4 out of 5 companies fail, and if you were involved in one of those companies, and if that's going to be a blot on your career, that people are always going to say, yeah, well, you had that company that failed, that's not good. But I don't perceive that you have that culture here. Again, people wouldn't be doing this stuff with all these startups if they thought that a failure was going to be held against them for the rest of their life. At least that's what I think. You've got federal and city programs that encourage new business development. You've got all this electronic stuff, e-stuff going on, which I think is great. You've got entities like Startup Estonia, and you've got industrial parks. Go down a level to Tallinn. Again, I think it looks to me like a startup-friendly city. I ran into this test in Tallinn program where the city has invited companies to come in and test their products, their prototypes here. You've got some really important pillars. We're in one of them right now. We're in 2 of them right now, Taltech and Mektori. Technopol is right next door. These are really important organizations in this ecosystem. They do a lot of work. You've got the entrepreneurship training at the academic institutions. As I count, you've got 3 industrial parks, 2 science parks. They have space, provide space for companies as well as employees. This employee thing is really important because as I look at it, you've got a good technical workforce here. So in the United States, people are unwilling to move to take a career in a city where they don't think there's any other job prospects. So if the company fails or they want a new job, if they can't look around and find another job fairly easily, they don't want to move there. So I think the fact that you have a broad technical workforce here is great because it means there's mobility for these people. Very important in the United States. You've got incubators and accelerators that provide mentoring, co-working spaces. You've got some reduction to practice funding. I think Prototron is one of those. I think you can use more, but everybody can use more. And you have some established investment funds and angel investors. I don't know too much about that, but I took this off of one of the, I think, Startup Estonia website. I come down to Taltech. economic development, innovation, entrepreneurism, contributing to society. I pulled all of those phrases out of the strategic plan, the 5-year strategic plan for this institution. So that tells me that the senior level people realize that this is part of the mission of the university, and that's great because we still don't have that at a lot of universities in the United States. You have entrepreneurship training, as I said before. Every student has to take at least one entrepreneurship course. You have R&D to generate the new ideas by US standards. You might be expecting 15 to 20, maybe new ideas. We call them invention disclosures in the United States. But you're going to have a deal flow here from your researchers. And as they get more immersed into the culture of this, you expect to see that probably go up. Your technology transfer program is growing. The number of people there that are in it are relatively new here, so it's growing and it's reaching out to faculty. You've got collaborative work with industry. Certainly part of, I think, half of Anumai's program is really trying to stimulate collaboration. I was shocked when I went to the Talltech website many months ago and saw how faculty members listed all the equipment that they have and the technologies that they have that they could collaborate with companies on. I was shocked. It was really neat to see that. And this one I walk through here several times a day, and this building itself, I think, is really important because this is where a lot of networking happens. A lot of people are coming together in this building, and I think it's great. Challenges. These are challenges that every university has, so I'm not singling out Talltech here. But, funding, this risk reduction funding for both the university and the startup, those funds are hard to get. And so there's always going to be a need for that. Experienced entrepreneurs, I imagine you have in Tallinn, you probably have a lot of IT-related people with experience, and engineering people, I can imagine. I don't know about drug development, for instance, but this institution isn't necessarily developing drugs. I worked in a medical school where that's what people were doing. So I think you do have experienced entrepreneurs here, but you can always use more. I don't know exactly what the investment, the private investment community looks like here, how connected you are to other sources in Europe, but there's always nice to be able to get the venture capitalists to come to your town is really important. We struggled with that for years in Seattle, even though Seattle was doing really well. We were tucked up in the corner of the northwestern United States, and people didn't want to fly out to see us. So doing whatever you can to try to attract investors to come and spend a day with you would be great. Developing your culture of tech transfer, we've talked about. I think there's still work to be done there, some really good work. One of the things I've noticed, again, when I talked with Mart and Alan about this opportunity to come here, I said, it looks like you got everything you need. So you got all these business parks and things, and I'm hoping that they work closely together because, if you have a bunch of programs and they're all like this, they look like silos, we call them in the United States. If you take those people and you got them starting to work together and their linkage, that linkage creates a much stronger environment than a bunch of silos. So again, this is not a critique. I just don't know how well all these different programs are working together, and I would encourage as much collaboration as possible. And then again, this notion of government, industry, and business working closely together, this idea of a round table, that is really important. That government knows. Government doesn't move very fast. They change their interests, So my Life Sciences Discovery Fund was supposed to be around for 20 years with $350 million. Well, they stopped it after 10 and $100 million. So, but it's really important to keep government, because government has a role in this. You know that. They're making grants. In our country, they created the whole technology transfer system. So again, those are challenges, but they're not unique to Tallinn or Taltech at all. We see those all over in the United States. And final slide. I've got my one word of Estonian here, aita. But I've had the opportunity to work with a variety of people while I've been here, 5.5 weeks. Certainly thank your Vice Rector for several really nice conversations. Basically this is his program about entrepreneurship. And Anumai, we've spent a fair amount of time together. She's telling me about her challenges and what she's trying to do. She's got the 2 different groups that are working with her to really doing more with industry. Alan and Mart, they hired me to do this. So back in March or whatever, they interviewed me, but both of them, Alan has been my closest contact. He's shepherded me around and make sure that everything's going all right. But it's been really great working with them. I've spent a lot of time working with them. In the office, Signe Berger, she really helped make my stay here really, really comfortable. So I'm living in the academic hostel, and it's largely through her efforts that it felt like home. My office mates, Mart, Andre, Kadi, Renee, Rhinus, it's been a really fun sitting in that room, exchanging ideas, and it's been really, really enjoyable. I've had the opportunity to meet with about, many as, maybe 10 or 12 different research groups, and that's been really enjoyable for me. It's been a long time since I've done that. And I can say that the quality of the research that I've seen is really, really high. And the application for a lot of that looked that there should be application. It's a matter then of figuring out whether it's going to meet an unmet need. But I think the work that I've seen is I've been really, really impressed with. And just everyone been very kind, very friendly, and I appreciate the hospitality. I was able to go to Helsinki for one day, and I didn't seek asylum there, but I was able to go back to the motherland. And then Fred and his crew, thank you, Fred, for for putting all this together and taping these things. I've given 5 previous lectures, and Alan has put those available to people. I don't know. We'll have to figure out how widely available those should be. But so, anyway, with that, thank you. I'm done.
Thank you, John. And I like to thank also the Fulbright Foundations and US Embassy with their support. John is here, and I hope that our collaboration will continue when you are back in United States, and maybe sometimes we are in United States or you are back in Estonia too. We will meet again and again. And now, as we have the internet recording and YouTube channel, you can ask the questions, but please use microphones. We have 2 people here with microphones, and who has a question can raise a hand and then ask. But I have a first question to you. You have been in United States in more than 30 years in technology transfer, and you have been in few time in Ukraine, and you have worked with Ukrainians in United States, and now you have been 5.5 weeks here. How can you compare Estonia and our opportunity? I saw you in your slides, but do you have some few sentences where to pay the most attention to us and how different we are from United States and Ukraine?
Well, I think the United States and Estonia are closer together than Ukraine. Ukraine, when I was only there for a week in Kyiv, met with a lot of investigators. I worked with them afterwards. They had a granting program, so I used to review grant applications. We had a group of 12 Ukrainians come to Athens, Georgia, and we put on a one-week curriculum for them about technology transfer. What I saw in Ukraine, the science was very good, but it was really underfunded. People were scrambling for money. There was really, I didn't see the kind of structure that we have in the United States about how to manage all this stuff. It looked a lot more, I don't know the right word, disorganized isn't the right word, but it looked a lot more flexible. In the United States, we don't always have a lot of flexibility. The university owns your discoveries, and you have to work through us. So, but again, the science I saw in Ukraine I thought was very, very good, but really underfunded, and just really trying to get a start on tech transfer. What I'm seeing here, again, I think really, really good science, good development. And as I said, I think you have all the right things. You have all these different programs around, and so the one thing is trying to build this culture of technology transfer. I started at the University of Washington in 1989. We were 8 years after the earthquake, or 9 years after the earthquake, as I described it, and the program, when I got there, was sort of revamping itself, and so it was almost a startup again. And so we spent a lot of time just going out and talking to faculty, and in the venture capital world, you'd call that we were trying to increase the deal flow. We wanted to see more ideas coming in, but again, faculty, I told you, there were hardly any startups, 1989, coming out of the University of Washington in my sphere. And so it took time. It took 5 to 10 years to really develop that. So I think Estonia is, to me, well on its way. And again, we're in a different environment because now it's a much more entrepreneurial environment. And but I think you're well on your way.
Thank you. Kaja has a question.
Yes, thank you. A very clear and good overview and all this speech. But my question is very strategic, and this is about IP ownership. We have discussion in our university about that, and I think this is a very crucial point for the general policy in the state as well. And what do you think, is it some kind of barriers or policy differences when the IP is owned by university as an institution, or by researchers or scientists as a persons, or entrepreneurs? We have different kind of opinions, but what do you think about this issue?
Well, I think you have to realize that I grew up in a system that was directed in a certain way, but I can comment on that. First of all, in the United States, we were told in 1980 that the university would own the IP, and at least for federally funded inventions. And we, as I said, we adopted that policy for all of the IP. If you've used university facilities, university money, university equipment to develop the IP, the university owns it. If it's something you did that's unrelated to your work and you did it in your garage or basement at night, then you could own that. But you still had to tell us about it because we had the ability to say, no, that's owned by the university. Unfortunately, in my work, I had to be a policeman for a while, where I had to go and see that faculty. We had one faculty member who had 12 patents. None of them were owned by the university, and I got to go knock on his door and say, so how were those developed? But, so I don't have really any experience, but what I think I've seen from a distance is that when the faculty member owns it, then you end up negotiating with your own faculty about what's your role versus the faculty member's role. And that's just not a good, for me, that's not a good role for the university to have in this. If the university isn't going to, so to me, the university owns it. If the university's not going to do anything with it, then you can offer it back to the faculty. But if it's federally funded, we have to offer it back to the government first, and then they would get it from the government. But if the university decides not to do anything with the invention, they can offer patent rights back to the inventors, but then they're going to tell them at the same time, you can't work on it in the university anymore. You can't use our facilities.
In our case, IP ownership is universities. But we have discussions, maybe scientists are much more motivated to commercialize this IP when they have the ownership. But of course, university needs to build up some kind of supportive systems. This is clear.
Well, if you don't have the system to support them exactly, but one of the things is they may want to own it, but wait till they start paying the patent bills. They're expensive. There's a lot of money there. So that's one of the things the university brings to the table. I have seen inventions go back to the faculty members, and after 2 years, they said that patenting just costs too much. We dropped the patents. So that is one of the things you bring to the table. The other thing is, as you said, the support and the expertise. And you've got a cadre of people now that have business expertise and they have technical expertise. So hopefully they'll realize that there is a structure there to support them. Yeah.
Thank you,
Yeah.
John. Any other question? From auditorium.
Thank you very much for this presentation. It was very interesting. And for me, it was particularly interesting when you were speaking about the risks. And you spoke about risks connected to the institutions more. And you said that doesn't apply only to our university, that people tolerate the risks. But we have to think which people are tolerating the risks. When we look on particular project in university, well, it's part of big portfolio, and the risk is managed through this portfolio. But now when we look on the professor behind this project who is starting, he or she is taking very huge risk compared to just teaching and doing research. So my question is, and this is connected with Kaja's question very much, how to give certainty to these professors, or how to add certainty to these professors?
Certainty? Risk? Well, I think part of what you're, if I interpret your question correctly, part of what you're saying is, why should you be spending part of your precious time doing this, working on this risky thing? Is that part of it? Yeah, so I mean, I'm a professor, I'm teaching, I've got, graduate students, and I'm writing grants, and why should I be spending my time on this? And is it worth it? But I think, I don't have a good answer for that, but I think that's what every faculty member has to decide. So in the United States, don't get me wrong, we do not force this on people. This is for people that really think that they want to devote part of their precious time. And the people that do, again, I've been out of it for a while, but the people that I was spending more time with were more senior people who were tenured, and very few of them were teaching in the medical school. And so they did have some time, but I don't know that if there's any way you can provide certainty, unfortunately. Yeah.
The next question, please.
Thank you very much for your insightful presentation. According to those that was said to us, wondering what is about social sciences, how they can contribute to the economical development if we speak in terms of patents, licensing, and so on.
Those, there were 6 schools in the health sciences, medicine, dentistry, but one of them was social work. And I think I had one invention report out of the social work program. But I also saw some other things out of the nursing school. And generally what I would see from them were, trying to think of the words, like standardized tests that you would use for assessing somebody. Does that, the MMPI, the Minnesota Multiphasics, the MMPI? So there are standardized tests that have been developed where they're questionnaires, and you use the answers on that questionnaire to diagnose or predict or something like that. And so that's what I would see. People had those and they were validated. So their research validated those questionnaires. And people wanted to license those. People wanted to use them. So again, it was up to the professor to say, I'd like to give this away for free. But it was at other times it was, no, I don't want to give this away for free, because people were worried that maybe in that case they would add their own questions to it, and then the tool that they had created would become something different than they had validated, and that might then detract from the utility or the reputation of the tool. But that's the only thing that I can think of right now. Are you thinking about other things that, yeah. So those kind of tools, in the age, that's a whole other thing. Yeah, I'll leave it at that. Yeah.
I have a question from the internet, a little bit moderated. What do you think about the impact of the technology transfer to the world's future?
Oh boy. Well, I come from the biomedical side, and I think there could be a lot more done by big companies to make drugs and vaccines and things like that more widely available. I think that's a situation where patenting isn't always in the best interest of the world people. companies have addressed that, but I think on the biomedical side, there's work there to be done. On the other side, other things, clean water and hygiene and, other, power, other requirements that countries need. People are always working on that, but they often can't pay for the solution. And, that's where charity comes in. It's not necessarily a business model because it's more of a charitable model. So Gates Foundation we have in Seattle, tries to make things like that available. There are a variety of charitable foundations, but I'm not sure that that's an area where patenting helps. I'm not sure. Mart, I'll talk to you about that later, but I don't think intellectual property, those are maturing markets, but again, there's not a lot of money there to really have companies develop something specifically for those markets. And then again, that's probably more of a charitable activity.
Yes. Thank you, John. Any more questions? Yes, please.
Oh, Andre.
So, John, thank you very much. It was excellent lecture, as all those that were before this. You mentioned tangible assets or tangible, property. So like, for example, I understand this as a material, maybe some kind of like associated with material transfer agreement. So my question is that, is it, how do you think, is patents that depend also on materials coming with it stronger, like intellectual property compared to patent based on maybe process or something like that?
That's a good question.
Thank you.
I don't, I've been out of this long enough to know where the world stands on patenting organisms and software. I think there's been some stuff there. But if you can get a patent, that is probably good. That's probably better. But actually having the material in and of itself, as opposed to somebody having to develop that on their own, they could work hand in hand. But we have plant patents in the United States on new plant varieties. University of Georgia has a very, very active plant program for licensing. But probably the patent is stronger, but patent has a certain lifetime, and some of these tangible materials have a much longer lifetime. So it's probably a good combination if you can do it. Yeah.
Yes, we have 3 minutes left.
Right on time.
Opportunity for last questions, please.
Rene.
Thank you, John. I've been asking you every day for the
Good.
5.5. But wanted to say thank you for encouraging us. As you said, we have all the pieces actually in place. We have to make it work. And from today's ideas, I think we should bring more government and companies closer to us and make some kind of roundtables quite actively. So that would lead us in a even better place. But for the broader audience also, that we are now just in the process of refreshing or restarting tech transfer activities, and John has been there every day and evaluating everything what we're doing. So that has been a super exciting and exciting time with you. And at first I thought, 6 weeks is gonna be like, enough, but no.
So exciting for you, and for me it's been fun. So it's been a lot of fun. Yeah.
So thank you once again. No questions, but
thank you, Rene. I appreciate it.
Thank you, John. And now I like to ask technology transfer guys and ladies to join with John to have a common picture, and rest of the audience can see who are the technology transfer guys in university, whom to speak. Tänan. Vaatamegi, jaa, meil on pilditegija äkki. Kas